Okay. So now let's see how we can use the same, unit circle. Let's see how we can use it to get the angle that is missing. So we probably have to redraw the triangle. You see, now in this triangle, this x-axis is √2/2. This y-axis is also √2/2. So let's redraw the triangle. Let's redraw the triangle. 90-degree, y-axis √2/2, x-axis √2/2. This other side is 1, and the angle here is theta. Now here comes when we need the what? The SOHCAHTOA. Here comes when we need the SOHCAHTOA. All right, because the second question says determine the angle made by the coordinate x and y. So now let's see. SOHCAHTOA, always write it so that you don't forget. SOHCAHTOA. Now here is our opposite. Here is our adjacent, and here is our hypotenuse. So invariably we have the 4 sides. Actually, the 3 sides, I'm sorry. So now, which of these trigonometric ratios do you want us to use in order to get the angle?
We can use adjacent over hypotenuse.
Okay, so you're saying we should use cos, right?
Yeah, cos.
Okay, so then let's see. Write your formula first, which is cos theta is equal to adjacent over hypotenuse. And adjacent is cos theta. Adjacent is what? √2/2. Hypotenuse is what?
1.
1. And remember, any number divided by 1 is the same number. All right, so which means cos theta is √2/2. √2/2. All right, so now does that give us the angle by itself? The answer is no. So how do we get the angle? Let's work a little bit further. So can you use your calculator, please? Use your calculator and divide √2 divided by 2. Somebody did it before, but this time around, give me a longer number, like 4 places of decimal. I'm waiting.
0.7071.
0.7071. Thank you. Now, in order for us to get the theta, we have to get the inverse of this number. So we are going to say theta is going to be cosine inverse of 0.7071. So let's try to, let me share my own calculator right now because that becomes necessary. Give me a moment. Okay, so my calculator is ready. All right, so now we are looking for inverse of cos. So you can see it is on the blue side, the blue button. So for us to get to the blue button, we have to press second function. So we just press second function, cosine, and then we type in the number 0.7071, and then you close the parentheses and you hit enter. Boom. Look at what it gives us. That's 45 degrees. That is 45 degrees. So let's get back to our screen. So it means the angle is equal to 45 degrees. All right. the angle is equal to 45 degrees.
Question. So we do all this when we want to find the angle of the.
Yes, if you are finding an angle, if the coordinates are given, that's what you do. On the other hand, the question could be find an angle. The question could be find one of the coordinates. You see, I might give you another coordinate, like a coordinate, I might give you y, and then you'll be asked to find the x. So it depends. But as long as unit circle is, the radius is not going to be more than 1. And they don't really have to call it a unit circle. They can just say a circle with radius 1 has the following coordinates. Then they may give you the x or the y. And it will be your responsibility to sketch the circle the way we just did. See how we sketched this one? You just draw in a circle and write in the radius to be 1. See, you just drew a circle and let the radius be 1. And then you pick. By the way, this coordinate could be in the first quadrant, it could be in the second quadrant, it could be in the third quadrant, it could be in the fourth quadrant. Okay? And each of these quadrants has x and y axis. So if it's for example, here, let me expand this a little bit. Let me make it bold. Okay, if it's on this quadrant, you can see that the value of x is going to be negative and y is going to be positive. If it's on this quadrant, you will see that the value of x is going to be negative and then the y is also negative. So here, x comma y is going to be negative and what? And negative. Here, x comma y is going to be negative value and positive value. Here, if it is this side, like here, so x and y is going to be, x is going to be positive value and y is going to be negative value. So it can just come into any of these coordinates. All right. Okay, so now here's the next thing we are going to do now. We are going to use this unit circle to derive our second trigonometric ratio. Or we can repeat what we did before. Let's actually do that so that, let's actually do that. Let's redraw the triangle. I'm redrawing the triangle right here. Just for clarity, just to, so that we will be looking at the triangle at the same time. This is your theta. This is 190 degree, y and x. And let's apply our SOHCAHTOA. Okay. So let's say sine theta would be, of course, this is your opposite, this is your adjacent, and this is your hypotenuse. So sine theta is going to be what? Always opposite of hypotenuse. So what is that?
Y over 1.
Y over 1, which is equal to what? Y sine theta is equal to y only, because any number divided by 1 is same number. All right, so you can call that equation 1, and then you repeat the process for the 3 trigonometric ratio. So cos of theta would be adjacent over hypotenuse. So what is adjacent now? Hello, guys.
X over the adjacent is x.
X, thank you, over 1.
Yeah,
so,
X over.
And any number divided by x is 1. So we write our cos theta is equal to x. Okay. So next, let's do tangent theta. So you can call this equation 2. Tangent theta would be always opposite over adjacent. And this time around, opposite is y, adjacent is x. Okay? So you can call that equation 3. Now, let's bring all these 3 equations together because they have things in common. So let's bring all of them together in terms of the angle, thereby eliminating the side completely. So let's eliminate the side and, you know, work it in terms of angle. All right, so now we can see that equation 1, y is equal to sine theta. Equation 2, x is equal to cos theta. So we can say substitute equation 1 into equation 2. No, I'm sorry. Equation 1 and equation 2 into equation 3. So you're just making a substitution. So if you do that, you are going to get that tangent of theta is equal to what? Sine of theta, because y is sine of theta, divided by cosine of theta. So we wrote this formula before, so I'm just writing it again because it's also going to help us do something else right now. So that becomes our first trigonometric identity. So now there is one more trigonometric identity. Let's do it and then we will consider calling it a day. There is one more. Now, the second one will be based on the general equation of a unit circle. So what is it again, ladies and gentlemen? What is it? Look at your paper and tell me what is the general equation of a unit circle?
X squared plus y squared equals 1.
Thank you. That's correct. So we can say using the general equation of a unit circle. Okay, and that general equation is x squared plus y squared equal to 1. All right, so we can see from this equation 1 and 2, you can see that x is sine theta and y is, x is cos theta and y is sine theta. So you can just make the substitution right there. So this is cos theta whole squared plus sine theta whole squared equal to 1. All right, but the proper way of writing what I just wrote right now, the proper way of writing it is cos squared theta plus sine squared theta is equal to 1. That's the proper way of writing it. Or you can say that sine squared theta plus cos squared theta is equal to 1. So this very formula that I just wrote right now is called Pythagorean identity of unit circle. Pythagorean identity. So it is called Pythagorean identity because it is just derived from Pythagorean theory. Nothing more, nothing less. Nothing more, nothing less. So that formula is derived from Pythagorean theorem. All right.